Hello guys, and welcome back. This video is going to be about the area of regular polygons. Now, as a reminder, a regular polygon is any shape that has congruent sides and angles. So this will include everything from an equilateral triangle to a square to a pentagon, hexagon, octagon, all the way up to dodecagon. Okay, we have to remember that as long as it has congruent sides and angles, then it is a regular polygon. So let's start off with a bit of vocab. Now to start off with, we have an inscribed pentagon. So this is a pentagon that has been drawn inside a circle. Because it's been drawn inside a circle, that means that all the angles, as you can see, are touching the edge of the circle. Therefore, when you have a line drawn from the center to the angle, that is called a radius. Alright, I'll be calling this line a radius even if we're not in a circle. It's just going to be the radius. Now the new bit of vocabulary is this apothem line. Alright, this line goes from the center to the side of the polygon. It does not touch the edge of the circle, but it stops at the side, and it creates, by definition, a right angle with that side. This is one vocab word we will be using a lot. Okay, but all it is the segment that goes from the center of the polygon to the side of the polygon. Last but not least, this is a vocab word that we learned in circles, and we're going to keep using here in polygons, is the central angle. Now, as a reminder, the central angle is the angle that is on the center of the polygon, or the circle, in our case, the polygon. And the fact I want you to remember about central angles, okay, is that the sum of all the angles is 360 degrees. We'll be using this fact a lot. Okay? So central angle, the sum of all the central angles is 360 degrees. What that means is that everything around the center will create 360 degrees. Let's practice. So I'm going to give you a moment. Go ahead, pause the video, write this down in your notes, and make sure that you can name everything. And here is the picture labeled. So in this case, our regular polygon is a square that has been inscribed in a circle. So your radius is the line that goes from the center to the edge of the circle, which would either be kg or kh, or you could flip those letters and do gk and kh. Does our hk, doesn't matter. The apothem is still the side that goes, the line that goes from the center to the side of the polygon and forms a right angle. Okay, and that right angle bit is important to remember, because sometimes the problem will give you that it's a right angle, and sometimes you just have to remember. Now, the two central angles are going to be GKH, or you could go the other way around and do HKG. It doesn't really matter which way you go. What I do want you to notice is that when I refer to the central angle, I am referring to this big angle. But as you can probably start to see, currently we have two right triangles within this angle. Okay, so the central angle is always going to be the big angle, and I'll typically refer to one of this as either half the angle or GKL. One of the two. But it is GKL, angle GKL is 1/2 of GKH. Okay, just that you had that officially mentioned in your notes. Alright, what we're going to do now is we are going to kind of build the equation to find the area. So as I mentioned the other day in class, most of these equations have a certain logic to them. In fact, all of them have a certain logic to them. So at the very, very least, if you remember the logic of the equation, then you can create the equation for yourself. So let's get started. Now as I look at this picture, this is an octagon right here. And if I wanted to find the area of the octagon, there's a few directions I could go with, but one that's the easiest is I can draw triangles. Because currently I don't know enough information about octagons, but I do know a lot about triangles. And I know the area of a triangle is equal to 1/2 base times height. And so going off of that logic, I can think that if I had all 8 triangles, let's just say I had all 8 triangles, and I found the area of all of these triangles right here, and I added them all together, then that would give me the area of the octagon. Okay, so what I'm going to do then is I'm going to solve for this. I'm going to plug in my numbers. So the area equals 1/2 the base times the height. Well, base is 4. This is the base of my triangle. The base is 4. And then the height of my triangle is 3 here. Okay, and let's say I want to multiply the whole thing 8 times. That way I have all 8 triangles. Okay, but let's pause for a second and see what we've written down. This 8 is the number of sides. So I have this side is 4, this side is 4, this side is 4, 4, 4, 4, and 4. If I multiply 8 times 4, essentially what I've done is add up all the sides of the polygon, which is the perimeter of the figure. Okay? And then number 3, this 3 right here, that's the height of the triangle, but it is also the apothem of the polygon. So the equation for the area of a polygon is 1/2 the perimeter of the shape times the apothem. And this is the official equation for the area of a polygon. Now, you can also write this as the area is equal to 1/2 the apothem times perimeter. Okay, both work and both will be used interchangeably. Now, just like the other problems, you have 2 different pieces. You have the perimeter and then you have the apothem. The majority of the work for these kinds of problems is going to go into finding your pieces. So as you approach a problem, make sure that you're always keeping an eye on that you're trying to find the perimeter and you're trying to find the apothem. Once you get those 2 pieces, you can plug in and solve. Let's practice. So in this one, we have a regular pentagon. So I'm going to draw my regular pentagon, and it has been circumscribed about a circle. Now remember, the word circumscribed means that it has been drawn around a circle. And here we have our pentagon. It's not the best, but it'll work. And here we have our circle that is inscribed inside the pentagon. Now the circle has a radius of 8 millimeters. The radius goes from the center to the side of the circle. So always pay attention to the definition of the word. Center to the side ends up being our apothem, because in a better picture, that would be a perfect intersection down there. Okay, and the apothem always intersects with the right angle. And if you remember your vocab and your properties of circumscribed polygons, you would know that that side is tangent to the circle. So more proof that this is the apothem. All right, and we got to find the area. So again, the area is equal to 1/2 the apothem times the perimeter. Well, as I'm looking at this problem, I've already got one of my pieces. I already have the apothem. So now all I need to do is find the side. And then I can multiply for the perimeter. Now currently I don't know a whole lot about anything else. But I do have a right angle, and I do know a lot about right triangles. So I'm going to go with that. I'm going to draw a radius, a line, from the center of the circle to the edge of my polygon. This is a radius for the polygon. And now I have something to work with. Now normally, whenever I have a right triangle, I first think of Pythagorean theorem. But currently that's a bit useless because Pythagorean theorem requires 2 sides and I only have the one. So now I need to go to my other methods. And my other methods for right triangles are special right triangles and trig. Okay? Now both of these require knowing an angle. I don't know a whole lot about this bottom angle down here, but this angle up here is part of a central angle. So if I were to extend the radius and draw a radius over here, I would have the big angle is my central angle, and as I mentioned earlier, this piece right here is half of the central angle. So if I can just find that central angle, then I'll be good. Now the way you find that central angle is using the fact that all the angles add up to 360. So I'm going to do 360, and I'm going to divide by the number of sides I have. Okay, because essentially there are 5 main central angles going on in this picture. So I want to find this one right here, so I'm going to divide by 5. It's going to give me 72. But remember, I only need half of it, so I'm going to divide by 2 again, and this will give me 36. This angle right in here is 36 degrees. Okay? Which means, as I'm looking at it, I can't use special right triangles, but I can use trig. So I'm going to use trig to solve for this side down here. So I have SOHCAHTOA. And I have 8, and I need x. That's going to be tangent because I have the opposite side, or I have the adjacent side, and I need the opposite side. So the way this is going to write down is the tangent of 36 is equal to opposite over adjacent. It's going to be x over 8. And then as we solve, I'm going to multiply 8 to both sides as a brief reminder. 8 to both sides, and I have 8 times the tangent of 36 is equal to x. Now, if you haven't already figured it out, you will need a calculator for this portion. As I'm pulling out my own calculator, I'm going to remind you that whenever you are dealing with trig, you must have everything carried out to the 4th decimal place. Until you are ready to put a box around it, it needs to stay in the 4th decimal place. Okay, so 8 is going to be, or x is going to be 5.8123. Don't round, just write out to the 8th decimal place. Now, I don't actually care about x. What I need is the side length, because that's going to be able to give me the perimeter. So, in order to find the side length, I'm going to multiply this whole thing by 2. So that big number gets multiplied, the long number gets multiplied by 2, and therefore the whole side length is 11.6246. Again, 4 decimal places, do not round. Now that I have my side length, I can multiply that by the number of sides and have that my perimeter is equal to 58.1234. With my apothem being 8, I can go ahead and plug everything into my equation. So area is equal to 58.1234 times 8 divided by 2. Off to the side, I am using a calculator. And since we are ready to box this answer, this is the official answer we're turning in. I'm going to round this one to the 2nd decimal place. So I have 232.49 millimeters. Now, a couple of things before we move on. You may have noticed that I did a lot of work on the calculator. Okay, I found my side length with the calculator, I found my perimeter with the calculator, and then I did all the math on the calculator to find the area. There's a lot of calculator work that can be done. I still need you to label your picture and show me your setups. If all you have is an answer, then you're going to lose a lot of partial credit if your answer is wrong. So you can see from what I did, there is still plenty of work. There is still plenty of things that are labeled. This is appropriate amount of work for any given problem. Okay? Number 2, I want you to notice that there is a bit of flexibility involved. Okay, I had special right triangles as an option, I had trig as an option, and then I had the apothem and I had to find the side length. Like I said earlier in the video, majority of the work for these problems is finding the pieces. Okay, you could be given the apothem, you could be given the radius of the polygon, you could be given a side length, you could be given the perimeter, and now you got to work backwards. Okay? I could give you a piece of information that has nothing to do with the pieces you need, and you have to solve for what you do need. So when you're doing these problems, always maintain a certain level of flexibility and keep some prior knowledge in the back of your mind, because you never know what you may need in order to get what you actually need. Alright, last problem. What I want you to do, pause the video, see how far you can get on your own, and when you play, we'll go over it together. I assume you have paused and you're back. So let's get started. We need to find the area of the pentagon. So, as a reminder, the area is 1/2 the apothem times the perimeter. Looking at my picture, I see I'm given nothing that I actually need, which means I'm really going to have to solve for that stuff. So again, I have a right triangle. I'm going to be looking for this small angle right here, which is going to be half of my central angle. Now, for those who have noticed, this is the exact same pentagon as the last problem. Yes, the angle is going to be the same. I'm going to solve anyway. That way we can remember and review how to find that angle. So you're going to take 360, and you're going to divide by the number of sides, in this case 5, which gives you 72 as my big central angle. But I don't care about the big central angle. I need half of it. So I'm going to divide that in 2 again and get 36. Now I need my apothem and I need the side piece over here. I can't use Pythagorean theorem because I only have one side. I can't use special right triangles because I don't have a 30-60 or 45-45. So I am left with trig again. Which, if you like trig, this is going to be a fun chapter for you. Okay, now my advice on this problem is to do 2 rounds of trig, and here's why. Number 1, whichever side you solve for first, A or X, you're going to have a decimal to the 4th place. If after that point you choose to go Pythagorean theorem, that means you're squaring a pretty long decimal, which, since you guys don't like big numbers, may not be the best of ideas. The other reason why is if you have 2 rounds of trig, you're going to use that side 10 twice. And it's just always nice to use a whole number when you're doing trig. The fewer decimals that are floating around your problem, sometimes the easier life gets. So I'm going to solve for A first, for no other reason than I like A better. So A is adjacent to my angle and 10 is my hypotenuse. So that is going to be the cosine of 36 is equal to adjacent over hypotenuse, A over 10. Need to multiply by 10 to get it out of the denominator. It gives me 10 of cosine, or 10 times cosine of 36 is A. Now I'm using my calculator off to the side. And you should have gotten that A is equal to 8.0901. Which is actually very similar to the last problem. It's not the same as the last problem, keep that in mind, but it is similar. Okay, next I'm going to solve for x. Now x is my opposite side, which means I'm using sine. So I have sine of 36 now, and that is going to be equal to x over 10, opposite over hypotenuse. And you solve the same way. As I'm plugging into the calculator over here, I want you to remember that your calculator should be in degrees, and you can always check to see if you have it in the right degrees by doing the sine of 90. Sine of 90 should give you 1. All right, and x is 5.8778. Okay, but I need the full side length. So I'm going to multiply that number, x, by 2, times 2, and this gives me 11.7557. Now I'm going to take that number, my side length, and multiply that times 5. And I have 58.7785. Notice how all my decimals are still to the 4th place. I have not rounded yet. So now that I have my perimeter and my apothem, I can plug in. So A is equal to 58.7785 times 8.0901 divided by 2. Now, in case you're wondering why I wrote that all out, number one, it's always good practice. As I said earlier, there's not a whole lot of math that you can physically write. I'm doing all this on the calculator over here. But number two, just in case your calculator resets or you do wrong math, you always want to have your base equation written down. That way you can always come back to it. Also, as you're doing your homework, you want to know where the magic number of 237.76 came from. So always write down that equation before you plug it into the calculator. All right, and then since this is the answer we are boxing, I'm going to round now, finally, to the 2nd decimal place. There are my units, and there's my answer. All right, this is it. The homework is already posted. If you have any questions, please make sure you write them down so you don't forget, and I'll see you next time.